That's right, I believe in you. And today we're going to be multiplying decimals using the standard algorithm. So when I talk about the standard algorithm, I really just mean the traditional way that we've mentioned about how to solve these multiplication problems using decimals. So, Melissa, this is our word problem. Melissa is making fruit punch. She wants to make 2.5 batches using the recipe shown. How much cranberry juice should Melissa use? So right here, if I'm looking at this, there's information I do not need. But I can look for cranberry juice, and I notice that each batch of this fruit punch needs 1.5 liters of cranberry juice. What math operation do I need to do in order to solve this problem? Multiplication. So I'm going to come on over here, and I'm multiplying the number of batches by the number of liters of fruit punch in each batch. So it's 2.5 times 1.5. Now what I would really love for you to do is first to just quickly estimate. Doesn't have to be a big estimation, but I look here, 2.5 to me is close to 3, or if I round up to the nearest whole number, this can be rounded up to 2, so my answer could be about 6. So it will not be 60, it won't be 0.6, it will be about 6. So now I ignore my decimals and I go about this problem like it is a regular multiplying 2-digit number problem. So 5 times 5 is 25. I'm going to bring my 2 up here. This might get a little messy. So then 5 times 2, 10 plus 2, 12. Just because we're multiplying decimals doesn't matter. I still need my 0 here. So I know 1 times 5 is 5, so it's 25. Now I add them. 5, 7, 3. I know my estimation's an overestimation, but I can think, okay, where does my decimal place go? Where would I think? Here, but I also know my other strategy, which is to count up the amount of numbers behind the decimal point to figure out how many numbers should be behind the decimal point in my answer. So here's one number behind the decimal point. Here's another number behind the decimal point. So in the problem, there are 2 numbers behind the decimal point. So there should be 2 numbers behind the decimal point in my answer. Even underline them. Done. So my answer is 3 7/75. If I look at my estimation, I'm close. I knew this was an overestimation, but I'm still pretty close. So let's try one more. This one's the numbers are a little bit more challenging to work with. But when I see it written this way, I want to line it up the other way because it's just easier for me to see. So 4.3 times, well, I could put the 0 here, but I don't really need it. 67/100. Estimate. 4.34 67/100. I could estimate to either be 5/10 or 1. So I'll make it 1. It's 4. So ignore the decimal points and let's get started. 7 times 3, 21. Carry the 2. 7 times 4, 28. 29, 30. Put a 0. And then a 3. Now I put my 0 down here, and here we go. 6 times 3, 18. So here's my 8. Carry my 1. 6 times 4, 24, 25. Now it's also important to make sure you're organizing this. So if you need graph paper, you're welcome to use it. So using the standard algorithm, or the traditional way of thinking about this, we're supposed to count up the numbers behind the decimal point in the problem. So that's what I'm going to do. I'm going to get a red pen and I'm going to circle them. So here's one number behind the decimal point. There's another number behind the decimal point and another number behind the decimal point. So there are 3 numbers in my problem that are behind the decimal point. So it needs to be 1, 2, 3 numbers behind the decimal point in my answer. Is this number pretty close to 4? Yes. So then 2 and 881 thousandths is my answer. Okay. So now I want you to just try your best on these problems. Please fill out the Google form and submit it. I'll be coming around to check and see how we're doing.